Hi friends, welcome to the coding challenge by Asim Jain. So today's challenge is to sort an array using the insertion sort. So let me tell you how the insertion sort works, like the high level. So we will be given an array and we'll divide it in two parts, like logical two parts. Sub array on the left will be sorted and on the right will be unsorted. We need to get the insertion key. For example, it is here. We will check it and move it to the sorted side. So let me explain you with the code and then we'll come it here as we implement. So we would be doing it in a test driven way. So which means let's first run our tests to make sure that our tests are failing, and then we'll make it pass as we do the test driven development. Cool. So now let's make it pass. So first thing is we have got a array, like this is our array, and then we are passing it to a method sort, which we will implement. And if the implementation is good, this test will pass. So let's begin coding. So we'll iterate our element to the length of the array. That's it. That's the first. So the order and like the big O notation for it is O n square. So we need to do the nesting array. But before doing this, let's get back here. So we took an element, and then that would be the right side is supposed to be the unsorted array, and left side would be sorted. Let me write this first. So first thing first, we will get the insertion key, which will be used in the algorithm. So our insertion key, I'm naming it as IK, and then that would be the very first element in the upper array. And remember, we are starting it by 1. I'll tell you the reason why. Then we will have the index j, which would be I minus 1. So if you start with 0, 0 minus 1 will be minus 1, which will give us the index array out of bound, which we want to avoid. Now we'll have a while loop, and then so what this while loop would do essentially, this would try to compare the unsorted array. Actually, it would compare the sorted array with the insertion key and move to, or shift to right to make place for the insertion key to be placed. So let's look in the code. So first thing is j, until and unless j is greater than or equal to 0, and the element at jth, like the jth element, is greater than our insertion key. So long as this condition is true, the loop would be going. Now this is the comparison what we did basically with the insertion key, and then we also are making sure that j, now why j is greater than o, I'll tell you in a bit. So now the very first thing is we would make sure that element j plus 1 is supposed to be greater, but if in case it is not, like if j element is greater, then we will shift the j to j plus 1. So j plus 1 will get overridden basically because j, since it is greater, so we have moved it here. Now we will do j minus minus, like we will decrement it. So long as a of j, like so long as whatever the element at the unsorted place is bigger than the insertion key, we will keep shifting it right. So at the last, what would happen, like either we would come to the 0th element, or we would have the condition where the element at j is less than ik in the sorted side, like the logical side of the array. So this is probably the place where it needs to be stopped, like 6. So now we will do is we would put the insertion key at the location which we got here. So to put the insertion key will be ik, which is simple, but at what location? So j plus 1. Why j plus 1? Because we have done, like, after this we have decremented it. So just to get the same place which we made for a like j, we are doing this. So once we do this, I believe we are all set, but let's check. We have a test case to cover it up. And cool, this was our initial array. Then we did the sorting, and that's how it is happening. So we are able to do our challenge. Now in each pass, the subarray on the right side, which is supposed to be the unsorted, this gets overtaken by the left logical array or the subarray, in an incremental way. So congratulations, we just did it, and thanks for watching. The code is available on my GitHub. You can get it from the description, and bye. Have a nice time.